In this video, we're going to do another titration calculation example, similar to the one we did in the previous video. After you're done this example here, you can try the pause, try, play activity, where you essentially start the video, look at the question, pause it, try it yourself, play it, see if you're on the right track. There's a bunch more practice problems you can try here for titrations. So let's go ahead and try this problem out here from our handout. So here we go. We have a 25 ml sample of HCl is titrated with 1.0 molar NaOH. The endpoint is reached when 67.5 mils of the base has been added. Calculate the concentration of the acid. So that's what we want to know there, the concentration of the acid. Let's first of all start writing out our reaction. So we have HCl, AQ, plus NaOH, AQ, that's our base. It's going to be a neutralization reaction that happens. And we get some NaCl in there. That's a 1-to-1 ratio again, plus H2O. Our base and acid are 1-to-1 ratio. So what does that look like in a titration situation? So it would essentially be, so we have our flask over here. This is our flask. And we'd have 25 mils, 25.0 mils of hydrochloric acid. And we don't know what its concentration is. So we have our volume is 25.0 mils. So we used a better measuring tool there. So that's going to be about 0.025 liters. We don't know the concentration. We want to find concentration. C is equal to N over V. We just need the number of moles, and we don't have it yet. But we did an experiment. We took some NaOH. We knew some information about it. We put it in a burette over here. So we had some NaOH. Its concentration was 1.00 moles per liter. And let's say we started off at, I don't know, if we started off at, let's say, because you can start off at different points in the burette. Let's say I started off at 15 milliliters. Let's just say that. I'm not putting decimal places there like all of them. So let's just say 15.0 milliliters. So that means I would have to end up at about, I'm just making these numbers up. It could be any difference. I could have been at 0 and then ended at 67.5. It doesn't matter. Let's just say I started my titration where I started off, I just filled it up to 15 on the burette and ended up at 82.5. So 82.5 minus 15 is 67.5 mils of base that must have been added until my color change happened, until my endpoint was reached. And that's why I know the titration was over. So I can use that information there to figure out my concentration of HCl. So in other words, my NaOH, its concentration is 1.00 moles per liter. The volume added was 67.5 mils, which is approximately 0.0675 liters. And now what I can do is I can find step 2, I can find the moles of NaOH to help me find moles of HCl. So remember that the moles is equal to C times V, which is equal to 1.00 moles per liter times the 0.0675 liters. Cancel out liters, and I get 0.0675 moles. Now that I have the moles of HCl, 0.0675 moles, I can find the concentration. I can do C is equal to N over V, which is equal to 0.0675 moles over the volume, which is 0.025 liters. So let's go ahead and do that in our calculator. And we get about 2.7 moles per liter. The smallest number of sig figs appears to be 3 sig figs, so I can do approximately 2.70 moles per liter. So you can write, therefore, the concentration of the acid, which was HCl, is approximately 2.70 moles per liter. And we used our known NaOH to help us find our unknown our concentration that we didn't know for our HCl. And we can go check our work. So you'll notice the answer keys are over here, so you can double check your work. And this is an answer key here for some of the questions that you might have. And we get about, that's right, 2.70 moles per liter. And so that was another titration style question, very similar to the one we saw over here, just some different numbers. It's good to know how to do a sketch. Understand also in the flask, which I should have added, I should have said there's also some indicator in there. It might be phenolphthalein, it might be methyl orange. There's different types of indicators there. They'll change colors at in different pH values. And notice that this is a strong acid, strong base titration. So at equivalence point, technically the pH should be close to 7 at equivalence point specifically. As usual, I could ask you to find the pH of your acid, not your mixture, but your acid. So the acid, if you wanted to find the pH, just to show you how you would do it as an extension, once you have the concentration of the HCl, that's a strong acid, you can write an ionization equation. So H plus Cl minus aqueous. Since the concentration here is 2.7 molar, and we have a 1-to-1 ratio balanced, the concentration of the H plus is also 2.70 molar. And so your pH would be the negative log of the H plus concentration, which is equal to the negative log of 2.70, I should say. And so you do the log of 2.7, and you do get a negative value for your pH, and that does work. 0.431363764, which is approximately negative 0.236431. And that's okay that you have a negative. You're not really going to see that very often in most of the chemistry problems you do, but we do see it here. I didn't ask you for the pH here. I'm just showing you an extension problem that you could have been asked if I were then asked to ask you for the pH of the acid that was in the flask. In the next video, we're going to take a look at a titration problem that involves data collection to see what it would look like if you were doing this in the lab.